Hello, everyone. Good morning and good afternoon from wherever you sit around the globe. Welcome to our Tech Talk today. My name is Jörn Plois, and I'm part of Configit's global marketing team, and I will be your moderator for this very exciting session. So manufacturers around the globe are facing increasing pressure in these times of global uncertainty. We all know that, and it's become more challenging than ever, maybe, to drive new business sales. Partly as a consequence, many companies are increasingly discovering a very valuable, but yet often overlooked source of revenue, the service and after-sales market. So that's exactly what we'll be exploring today a bit more. And more precisely, how a digital configuration thread can play a crucial role in unlocking potential in this area. But of course, rather than giving too much away myself, I'll let our expert speaker dive into the details himself. And it's my pleasure to introduce our speaker for you for today. Welcome, Heiko Markgraf. Heiko is one of Configit's most experienced pre-sales consultants, and he has been with us for more than 10 years now. So after the 10 years anniversary, Heiko, congratulations. Heiko has a background in electrical engineering and computer science. His professional career started at a large chemical plant, actually, and he has worked since then in areas like product engineering, manufacturing, service, and as well as software development. And our tech talk today should take about 30 minutes, the practicalities. And in the interest of time, I would just like to ask all attendees to kindly put your questions into the control panel on the right-hand side, and we will capture them there and go over in the short Q&A in the end. Over to you, Heiko, for your presentation.
Yeah, thanks, Jörn. Welcome, everybody, also from my side. Yeah, as introduced, we will talk today about more the after-sales area. So after we have sold the product, the customer is using it, how can we make continuously revenue with customers by offering nice services and so on. From an agenda point of view, we will start with, how can we keep our customers and why it is very important to think about new business models, services, and so on. We will talk a little about the typical new digital services and business models like predictive maintenance, contracts, over-the-air updates, and so on, so that we get a good overview and how we can work with these services. We will introduce a more configuration thread thinking instead of a very BOM-centric approach, as it is maybe often done today, and talk about what are the differences. And we will look at an example of an end-to-end variant management as well with a small demo how an end-to-end user journey could look like. At the end, a small roadmap. So if you would like to start making more use of your services and capabilities, where you could start to kickstart the service journey of your company. All that, of course, supported by our ACE modeling environment and our incredible VT technology. Before we jump into details, maybe some terminologies, some words, so that we all understand the same on a few words. If you talk about retrofit, then we talk about updating machines to new performance level, to newer components or something like that. It could be, as it is done today, very often a physical change that you maybe, like in a car, exchange the engine again with a newer one or a better one. But it could be also, as we see it on mobile phones, for example, that you get updates constantly deployed over the air, or that you maybe can buy new features later in the life of the product. All that change your product and is a configuration change after you have received the product. OTA updates, over-the-air updates, is something we all know from our mobile phones and other devices. And it becomes also more important for your customers to get frequently updates of not only bug fixes, but also performance updates and maybe enabling new features and functionalities on the products. So also over-the-air updates will become more important in the business life. And the last one, softwarization, very similar to electrification, where we have replaced mechanical components with electrical components, like a steering connection between the steering wheel and the wheels, replaced by electronical drive-by-wire cables. And in a similar way, we're replacing specific hardware components with software flags. So instead of having mechanical variants, we move the variants forward into the software, as it is way easier to enable and disable a software flag than a mechanical change. So moving over components more into the software, or variants more into the software, is kind of the softwarization we will look into here. Good, having some words, let's have an overview of how the world is today and how it develops. If we have a time span from, let's say, the last 40 to 50 years, we maybe can see that machines or products become more expensive. It can be because of labor costs, it's because of material costs, it's because of new innovations put into and so on. So we can see an increase in the price for the products. We also can see that there's a higher uncertainty on the market. I mean, I had that in a previous tech talk, that the world has again and again some crises. It feels like more and more often. And of course, it creates this kind of uncertainty. What might be in 5 or 10 years with your company? Will everything grow or not? So that's what we have to deal with today. We also can see that our machines live way longer. I mean, if we look at a car which 50 years ago, if it could do 100,000 kilometers, 200,000 kilometers, there was a big differences. Today, every car you can buy has nearly a very high durability. And in a similar way, it's also with our machines and other products. Then we can also maybe in some areas see that the sold units per year is going down. That's with, of course, related to higher durability. So you can use the product way longer. For example, your car, you can drive longer. There's more uncertainty, so you maybe think twice before you buy a new one. And there's also a higher cost, so you also have to have the budget, the money for buying a new machine, or you think about keeping the one you have. And what we also can see is that the innovation cycles become shorter and shorter, where we in the beginning had maybe 3-5 years where we have some new innovations. It is now feels like every moment we have something cool new coming up, which adapts and has to be implemented into our products. And we also can see that competitors are ways faster in catching up new innovations. So in the past, when we have released a cool new functionality, it took a while, a year or two, until someone could catch it up and has the same functionality. Meanwhile, we have a lot of open source, internet, knowledge sharing, and so on. So whenever you come up with a cool new idea, it might just take a month or two for the competition to get up to speed and offer the same. So also this time span is heavily reducing, so that you could say everyone is offering nearly very similar products on the market. And if not yet, then in a short future, they are also able to do that. And if you now look into some of our customers, like buying a machine many years ago, it was like, okay, it has a certain durability, it has a certain price, and there's uncertainty at that moment. But the innovation cycles you have missed by operating a machine for 5 or 10 years was maybe 1 or 2 innovation cycles. So it wasn't that bad. If you look at the same situation, if you buy today more a machine or recently bought a machine, then the uncertainty is way higher, the costs are higher, the durability is also higher, which is quite good. But we also can see that there are also a couple of changes when it comes to the innovations. So if you now operate a machine for 10 years, we're missing a lot of innovations. So customer expecting ways more often, getting updates and so on. Similar as we are used to have it on our mobile phones, on our computers and so on, where we get frequently new updates and also new features. Also, we need to enable that more for our customers using our machines and professional products. If you now turn into our customer view, and we will look at 2 examples of vendors offering a machine to us, then we can think about what is it really what we would choose. So let's take the view of our customers and look at 2 potential offers. The one offering is a fixed performance. So you buy a machine with a very fixed performance, which stays like that for a longer time. If you look at your expected growth, so we are today at the red mark. So the black line is kind of our growth in the past and the expected growth into the future. We are of course optimistic that our business becomes better. Then we have a certain expected lifetime of our new product. So that means somehow the new machine we buy has to target the expected performance during this period. So if you look at this vendor here, he's offering 3 different performance levels. So a low performance level, which is definitely under what we expect. A middle one, which is for a certain time of our operation quite okayish, and a high performance one, which is in the beginning too much, but at the end we're expecting we might need it. So most probably you maybe go with the highest one, so that your growth also in a couple of years is covered by that, so that also your production where you use your machine maybe can be fulfilled the growth. That means you have a certain total cost of ownership. Of course, it decreases a little bit over time as you do some services and so on. So that might be what you can expect. If you would go with the middle one, then maybe after a while you have to think about a new investment. So of course the initial buying would be a little cheaper, but it could be also after the half of the time you have to buy a new machine because it does not fit longer to your growth or your real growth here. So you are quite unflexible. So you can use a bigger machine with a higher price or the lower one. And the truth is, of course, it can also go down in worst case. If you look at a second vendor who offers a very flexible performance, which can be variable via retrofits or maybe also a product as a service offering, our starting point is the same. We have a certain expectation. If we now start with a medium performance level, and we can in any point in time kind of change our performance to a higher level when we need that, then of course that brings us some benefit. We have a low investment in the beginning, but we are sure whenever our business kicks up and we grow, we can update to this higher performance level. And that gives us, of course, a certain flexibility here and also offers us a cheap entrance here. That means our total cost of ownership would be maybe in average lower than what we would have if we buy directly the big machine. And if also possible, if you get it as a product as a service contract, for example, then maybe after each 3-5 years, when the contract is renewed, we can think about a new performance level. And maybe if our business goes down, we even could go with a smaller machine or downgrade the machine, which gives us even more flexibility here. And that's why these kind of service models and service capabilities becomes more and more important, so that your customers get the flexibility of using the product in the right way. And I'm pretty sure we agree on that the right side would be the one we would prefer, as it gives us a lot of flexibility in the uncertain market we are today. So let's switch back to our view. How do we deal with that in our company? But what we today do is, I would call it a bit BOM-centric approach. So what happens is we have in sales, we have our configuration. So that means during the sales cycle, the customer can be very flexible and choose a big, a small, a medium machine. And then once the customer buys a product, we convert the configuration into the BOM and the routings to manufacture it. And very often at that point in time, we just look at the BOM and forget about the configuration and so on. If you have multiple plans, we most probably have also different BOMs for the different plans, different routings and so on. That means also we have a variance in the BOM. Even the same configuration produced in 2 different plans might end up in different BOM. That means our configuration is in the beginning very flexible, and after customer bought it, it more or less stays very often on that state. If you now get into the service area, so we can see the variant management is much focusing on the sales area. And if you get into the service space, offering now spare parts is quite okay with that. So we can read the needed spare parts from the BOM and get the needed information. But if you now have, for example, the situation that we want to install a new software on a machine, then it will be quite difficult to figure out based on a BOM, can we install this new software version on it or not? The same for the service. So what would be the price for the service? So based on a BOM, it's quite difficult to read the configuration and figure out what service contract, what size is needed for a customer. How about features on demand? Can I buy a new feature based on this BOM? It's also often very difficult to figure out. The same for retrofits. They are today possible, but it's a lot of effort and manual work to figure out, I have this BOM, I want to get to that performance level or BOM, what is the differences, what is needed to do. So it's a very manually executed process. And if you have made a machine update, what is the consequences on your service contract? Does it need to change? So more performance, higher service contract price. All that is very difficult to just do with a BOM. If you look more on a configuration thread view, we would keep the configuration and we just derive the BOM from it. So of course we can derive the BOM, we can execute the production also for different plans, but we still keep the configuration as the main information of our product. And that enables us now in the service area to change the configuration more easily. So we can use a specific service model, service configuration, and make the changes, derive a new BOM from that, compare that with the old BOM, find the delta, and know exactly what we have to install or update on our product. So we can streamline this process. And that means we can more easily make changes to the product if the customer asks for. If you offer it as a product, as a service offering, then maybe the customer ends the contract after a while. That means the machine gets back to your stock and you maybe want to get it to a new customer. But that also means you maybe have to make some changes to the machine because it's often hard to find exactly the same customer who needs the same machine twice. So they also have very different needs for the product. And that is what we do with the configuration thread. We track the configuration over time, and we have all this. We can store all these different status and can support you on making these changes more easily as before. And you can see the variant management is no longer just focused on the sales area. It is covering the whole end-to-end journey and also covering ways more the sales area, because that's also some management. If you introduce new features, you also think about, can I deploy that to all products and all machines which are already sold on the market? And because we don't want to do every time a physical change on our product, we can think about softwarization so that we easily can make changes to a product without changing the physical product itself by just deploying new software flags to the machine and enabling a new feature, a new functionality on the machine, which is already physically there. You know that maybe also from other products in the car industry, it's already started to do that. When we look at softwarization, a small example here. if we have 3 customers with 3 different needs, we today produce 3 different cars because the one needs a small engine, the other one a middle one, and the other one a large one. That means I need 3 different production routines. I have to maintain 3 different motors or engines in my cars. I need spare parts for 3 different variants. And it's also hard to pre-produce products because you don't know what the next customer really needs. If you look more on softwarization, that means you produce just 1 variant every time with the largest engine, but by software, you limit the performance or capacity of the product. That means you have still 3 customers. You can still work on 3 different needs or offer a product for 3 different needs, but you have just 1 variant you have to produce with 3 different software flags or software information on it. And the big advantage is your production will be streamlined. You have just 1 product or 1 variant you have to produce in this example. The maintenance becomes way more easier. There are not 3 different products you have to train your partners and your service people on. It's just one product you have to have the maintenance routines in place. Spare parts, only 1 variant as spare parts and not 3 different ones. So that makes it more efficient to buy products in a higher demand or spare parts in a higher demand. And you also can pre-produce the product because in the production, you just produce now 1 car with a large engine. And then later on, when the customer comes in, you adjust by software what performance he might get. Of course, it has some disadvantages. I mean, the car has definitely a higher weight. And the higher weight might have an impact on the fuel consumption, on the lifetime of your tires, maybe. So that's something you have to figure out. Is it really a full consumption increase of 0.1 liter, or is it a full consumption increase of 1 liter? So you have to figure out what are the downsides of doing that. And that might be, of course, per feature quite different. You could also argument you have now more expensive parts. So the exhaust system of a large engine is way more expensive than for smaller engine, maybe. But as you have just 1 variant, you have to keep on stock for spare parts and so on. You have just 1 maintenance routine and so on. You also save a lot of money. So maybe that might be compensated by the savings you have on the other end. That means once you introduce new variants, you have to think about what is it really, what needs to be developed as a mechanical variant. I mean, color is quite hard to control by software. Fabric is also quite hard to control by software. But if it is something like air conditioning, yes or no, autonomous driving, yes or no, that might be something you could enable as a software variant. And theoretically, the car has all physically on board what it needs to autonomous drive, but it's not just enabled. And the nice one is also if you need to get that to a new customer, you can easily change the configuration and offer that to a new customer instead of finding a compromise. To enable that, you need an installation base which holds all the important information. And if you look at it more in detail end to end, you have a user in a service portal which goes in and makes a configuration. It transfers the configuration to a salesperson or a dealer. The dealer picks it up, does some negotiation, creates a new version in the configuration thread. You get into final negotiation, create the final configuration. That's what is bought. So you hand over the sales model now into production. You save the installation base, which is needed information for later services and so on. It has more information than the sales model in certain areas, also less information, like all the guided selling is maybe no longer needed, but you need to have information about what software is installed on your product, for example. And then you have dedicated models to read the installation base and convert that into, for example, the BOM and solve the BOM for production. You might have a retrofit model to offer retrofit. So you load in the installation base. With the retrofit model, you can easily configure and change certain information, like the manufacturing guy who is now installed the version 1.0 on the product can now save that into the installation base. And it will be, as you see, over time, tracked and extended. You deliver that to the customer, so it's the as delivered state now. The customer can go into a user portal, can maybe make some software changes, install a new software, get a new software product, so your installation base is continuously updated. Maybe also now he wants to have a service contract, so you need read the installation base, can easily offer a service contract, and then save both information together into the configuration thread, because whenever the installation base is changing, also the service contract has to be adjusted. Of course, the service contract could be bought directly in the beginning, but in this example, it's sold later on. And if you now do a retrofit, the more a physical one, then the information can be also transferred to the service technicians. They can go out, make the physical changes, the installation base is updated, the service contract is updated. So you really get a nice flow of the configuration through the lifetime of your product. And the nice one also, you can access the configuration thread very easily for reporting capabilities. That's also quite powerful. As you can see, the blue one, that's the area where we talk about CPQ, and it's just a very tiny part of the whole journey. And your competitive advantage really is here at the end where you have the services. I have a small example here, how that can look like from an end customer point of view. So we have here a dummy company called FastFiller. They're offering different products. We have here the configuration available. And we're selecting a forklift truck with a nice guided selling here for a product finder. We select an electrical type with some details about the product, select the product. We get into the configuration itself. So we see on the left side, the configuration, on the right side, 3D picture, pricing, and so on. We can, as usual, go through the configuration. Whenever some conflicts appear, our technology can solve that and guide the user what is needed to be changed. And you can now go in, make the configuration changes. For example, here with an open cabin, the prices, visualization gets updated based on that, enter some information about the fork distance needed, and finalizing the configuration right here. We can save now the configuration into the configuration thread as an draft configuration we maybe want to buy later on. So we have it stored. We can go back to our overview of the configuration now and can see all the details in there. We can now create a new revision of it. So we can create now a new revision as we saw it before, a new configuration in the thread, make some configuration changes like going in here into the cabin. Now have changed our mind. We want to have the closed one, but we definitely don't need an air conditioning for the moment. So we make the changes, get a new price, new picture, and so on, getting back to our preview. Now we are fine with that. So we can see here our history. We want to order that, so we add that to our cart. Get into our cart, have now the products in here. We can send an order to the manufacturer here, the FastFiller company, and we can now see in our My Products, here is the configuration with the status ordered. We can now execute a simulation of the production because we don't want to wait now for 3 months until it is done. And we have now updated the configuration here with the ordered status, with the manufactured status, and the as delivered is now the current status. And we can go in, for example, find some spare parts in here. So finding the spare parts. So we have support here from the visualization. We click on our tire, find the right spare part in here, select that one, order it, and can easily find the needed spare parts based on our installation base. We can record some service tasks maybe on our installation base, like, hey, now we have received the tires, we have exchanged the tires, so we can record that here in the log, for example, so that we have the full history here. And now we can also go in and make a product change. So we can ask for some updates, and here you can see now the retrofit model. So you can enable what type of changes you would like to see. Some information is hard to change, some can be easily changed, and you can see here the physical changes, the on-demand changes you can do, and the software changes. And the person can now go through and order or select the options which are relevant. So we want to have a working light. So after a while working with the product, we see, there was some options missed. So let's get this one. Now we also need the air conditioning. We before had deselected. The armrest might be maybe nice. And we also want to have some software updates later on, the auto braking as well. And then as an overview, we can get to the next step. You can see the differences. So what have we changed? What stays as it is? And we can get into an overview. For the features on demand, we also could offer that someone can buy it for a month or a half year or something like that. For physical changes, of course, they are applied and stay there. You can see the prices for it per month, for example, for the features on demand. And you just order it, and the installation base gets again updated after the physical changes are also installed. So you can see a nice history of your product and what was changed at which point of time. So how does that impact the digital twin? So the installation base, of course, is a very driving information now. And if your installation base changing, your digital twin might need to be informed about that. So you have your physical product and your digital twin. You may be recording already some sensor data of your physical products to offer some predictive maintenance, monitoring, simulations of factory execution, services and diagnostics. But it's now important as the product is no longer static. Whenever the installation base is changing, you also have to inform more or less your digital twin about that, because a simulation with a version 1.0 might be in different result as a simulation with a software version 1.5. So these information need to know about it. Yeah, last but not least, we have the roadmap to how you can onboard services in your company. And one of the important parts is that you have to think about what are the information you need to store in the installation base so that services can easily be executed on top of that. And then start recording these installation bases, because that's the information you need. If you want to update a 5-year-old machine, you definitely need to know what is installed. So start as soon as possible with recording your installation base in a proper way so that you can offer services on top of that. For features on demand, think about when you install a new or when you enable a new variant, could you provide that also as a software flag instead of a physical variant? And then start implementing them. So you can think about implementing first features as a software flag, and then start learning, using and doing it. Over the updates, start recording the versions and dependencies to your products in your installation base. So whenever somewhere needs a new version or could get a new version, you can inform the people and say, hey, here's a new version available for your product, and you will help them with installing it. Before you maybe move over to a more over-the-air update, it's often also a security topic. It's not as easy as updating a mobile phone. There's security and those are topics which are more important. So you really need to check if it can be done over the air or if you have to do it in a classical way. And then you also can enable and deploy new features to old products. And if you have all that in place, you can think about offering your product more as a product as a service, or maybe also with the help of your partner network. And that brings us to the finalization. So what we see is that even modern machines, they are which live for a very long time, they become technology-wise obsoleted after a few years. So we really have to deliver new features also for older machines to keep the customer happy and also competitive. And that's also what the customer expects. Customer will expect a more updatable modular product, which can be agile, adapted to the market and the demand customer has, similar as we have it used to our electronic devices at home. And that's what ACE and the configuration thread, as well our VT technology enables, so that we connect all the different pieces where configuration is needed and makes the configuration available to everyone in the company. So thanks for your attention. We run a little bit over time. I hope that was okay for the most of you. And yeah, if there's any questions, we can work on that now.
Awesome, Heiko. Thanks a lot. That was an excellent presentation. So yeah, let's open up the floor for your questions. As you said, we're running a bit short on time, but let's get on to one or two. Then we close it off. So we have actually received some great ones. So it's the first question, Heiko. Can I only save the configuration into the thread you talked about, or also other metadata?
Yeah, it is open to have also custom metadata on the configuration thread. So you maybe want to track what was the customer, what was the configuration details, or the application, which was the author of the configuration. So it is flexible to save some additional meta information. It is not supposed to save large files or cut drawings or something like that. You would do that with a link to the file or to the resources, which can be saved to the configuration, and then the physical file might be somewhere on a file storage.
Thanks, excellent. Thanks for clarifying that. So here's the next question already. So what kind of reportings can be done based on the thread?
Yeah, so the most common one is, of course, that you would like to understand what is your sold space. So there's a nice one on the configuration thread. It is not dedicated to a specific application. So for all your cross-application and sales channels you save it into one separate data storage. That makes it easily accessible for sales space reporting, so that you can see what configurations you sell very often, what configurations you maybe have never sold, to optimize that. With also configuration thread, you often have saved that in different applications, and it's often hard to access that. But you also can see what software versions are maybe out there. So if you know there is a critical bug in a certain software version, you could figure out what configurations are affected by that, and you more easily can reach out to the customer and install the software before something important or bad happens with the product.
Interesting. So here's probably the final question we can take in the session. So also related, so do I require a digital twin to track the configuration thread?
No, the short answer is no. This configuration thread is decoupled from that. Of course, if you have a digital twin, it has to be connected, because as I explained, the digital twin or the information stored in the digital twin might be related to the configuration which is currently operated. But you can start with the configuration thread also without having a digital twin. Just in case you already have that, it might be important to connect them both, but you can also run it without the digital twin in place.
Excellent. Thanks for the clarification on that. So that's unfortunately all we have time for today. So I want to take the opportunity here to thank Heiko and all of you for joining us today. And if you have asked a question or still would like to ask a question, you can still put it in the chat here. We will collect them and we'll respond to you following this tech talk. So I wish you a wonderful rest of your day.
Yeah, thanks. Bye.
Bye.